Gas laws, the important part of physical behavior of matter. Physical behavior, not chemical behavior. Here we will be talking about gases occupying the same space, being mixed together, but not reacting. If we plan to talk about gases, we first need to define what is a gas. Gas is any substance that fits a particular description, has properties of gases. So, gases have no specific shape or volume. They can expand and can contract. They can exert pressure and they have low density. So, any substance that has all these four qualities will be qualified to be called a gas. Properties of gases describe behavior of gases, their ability to occupy the entire container, their ability to exert pressure, and so on. So people were wondering what gives gases their ability to behave like that. To explain the behavior of gases, kinetic molecular model has been created. The kinetic molecular model is a way to explain the observable behavior of gases, why gases do what they do. Here comes the first statement of kinetic molecular model. Gases consist of molecules. The molecules of gases are not attracted to each other. That can explain why gases can expand. The molecules are not sticking together, so gas can expand, filling up any container it occupies. Second statement. Total space between the molecules of gas is very large. That would explain the low density of gases and their ability to contract. Third statement. Gas molecules are in constant straight line random motion. That's perfect explanation to why gases have no specific shape or volume. The molecules of gases will travel in the straight line in any given direction until they smash into the wall of the container. That would allow gases to take the shape of the container and occupy every part of it. The fourth statement. The fast-moving gas molecules collide with the container walls. They create pressure of the gas. That is a good explanation to how gases can exert pressure. The gas molecules move very rapidly. They have a lot of kinetic energy. And as a result of it, they collide with a great force into the walls of the container. This is how a very small mass of gas can exert quite a bit of pressure. Gas molecules are in constant straight line motion all the time until they smash into the container, then they turn around and they fly in the opposite direction. The particles may not have the same speed or amount of kinetic energy. However, we can measure average amount of kinetic energy of all the molecules in the gas sample. Think about it. What tool allows us to measure average amount of kinetic energy in a substance? Okay, here is the end of my mysterious pause. We can measure the average amount of kinetic energy in a substance by sticking a thermometer into it. By now you should remember that temperature is defined as the measure of the average kinetic energy in a substance. As we will investigate the behavior of gases, we'll be operating with certain measurements and characteristics of gases. So let's learn those characteristics and their units. First of all, pressure. Gases exert pressure. Pressure is defined as amount of force applied on a unit area. It is usually measured in pascals, kilopascals, atmospheres, or sometimes in millimeters of mercury. Here are some conversion factors that we might need here and then. Now volume. The gas occupies the entire container, so the volume of gas is defined as the amount of space of the container occupied by gas. Units of volume are liters, milliliters, and centimeters cubed. And here are some conversion factors that we might need. Now, temperature. Temperature is the amount of average kinetic energy of all the gas molecules. The units of temperature in science are kelvins or degrees Celsius. But here's the warning. When you will be doing any calculations that involve gases, the temperature must be in kelvins. Even if the temperature is given to you in degrees Celsius, you must convert it into kelvins before you do any kind of calculations that involve gases. This formula of conversion between kelvins and degrees Celsius can be found at the back of your reference table.